If I told you there's a state of matter that's neither liquid nor gas, but somehow both, you'd probably think I'm making things up. A magical substance that can dissolve diamonds, extract caffeine from coffee beans, and clean computer chips without leaving a trace. Welcome to supercritical fluids, matter's impossible fourth state. In 1822, French physicist Charles Cagnard de la Tours made an accidental discovery that would revolutionize chemistry. While heating liquid CO2 in a sealed glass tube, something extraordinary happened. The boundary between liquid and gas completely vanished. Above a specific temperature and pressure, called the critical point, matter enters a bizarre hybrid state. For CO2, this magic happens at just 31 degrees Celsius and 74 times atmospheric pressure. Not extreme by industrial standards, but the results are mind-blowing. Supercritical fluids have the density of liquids, but flow like gases. They can dissolve materials like liquids, but penetrate tiny spaces like gases. It's as if nature created the perfect solvent by combining the best properties of both states of matter. Now picture this. Your morning coffee. Did you know supercritical CO2 is already touching your cup? Traditional decaffeination uses harsh chemical solvents like methylene chloride. Not exactly what you want near your breakfast drink, but supercritical CO2 changes everything. At the critical conditions, CO2 becomes an incredibly selective solvent that dissolves caffeine but leaves the flavor compounds untouched. The process is remarkably gentle. Imagine tiny CO2 molecules flowing through coffee beans like water through a sponge, selectively pulling out only the caffeine. The best part, when the pressure drops, the CO2 simply evaporates away, leaving behind perfectly decaffeinated coffee with zero chemical residue. Over 99% of caffeine can be removed while preserving 95% of the original flavor compounds. It's chemistry that's both incredibly sophisticated and completely natural. The coffee industry isn't the only one benefiting. Supercritical CO2 is revolutionizing medicine manufacturing. Traditional drug production often requires toxic organic solvents that must be completely removed from the final product, a lengthy and expensive process. But supercritical CO2 can extract and purify pharmaceutical compounds with incredible precision. It can create ultra-pure medications, form perfect nanoparticles for drug delivery, and even sterilize medical equipment without heat or chemicals. One of the most impressive applications is creating aerogel drug carriers. Materials so light they re 99.8% efficient at removing pollutants yet can deliver medications directly to specific organs. These frozen smoke materials made using supercritical drying have surface areas larger than football fields packed into tiny particles. The possibilities are truly endless. Supercritical fluids are everywhere in nature. Deep ocean hydrothermal vents where life itself might have originated are powered by supercritical water at temperatures exceeding 400 degrees Celsius. These underwater geysers create supercritical conditions where water behaves like a universal solvent, dissolving rocks and creating the mineral-rich environment where exotic life forms thrive. Scientists believe supercritical water chemistry might be the key to understanding how life began on Earth. And finally, supercritical fluids are powering the green chemistry revolution. Traditional manufacturing often requires toxic solvents that pollute water supplies and harm workers. Supercritical CO2 offers a completely sustainable alternative. Major companies are already embracing this technology. Starbucks uses supercritical CO2 for decaffeination. Pharmaceutical giants like Johnson & Johnson use it for drug purification, and electronics manufacturers use it for precision cleaning. The process is incredibly energy efficient too. The CO2 can be recycled indefinitely. The same molecules used thousands of times. No waste, no pollution, no toxic residues. It's chemistry that works with nature instead of against it. This has been Supercritical Fluids, a chemistry that defies expectations and powers a better future.